I'm back into multi-tenancy game. Now you might say, hey, this is boring because you just explored a couple of videos ago Capsule, which sounds like an amazing solution to have multi-tenancy within a cluster. And Capsule does indeed sound like a better solution than creating a separate cluster for each tenant. Or does it? How about doing something in the middle? How about giving each tenant a cluster, but not a physical one? Because managing physical clusters is complicated. Managing different Kubernetes clusters is far from easy, especially if you need to have them on demand, if there can be many of them, and so on and so forth. However, if we could create virtual clusters inside a cluster, if we could do that, we would probably get the best of both worlds. We could give each tenant a separate cluster, but if that cluster is virtual, then operational cost wouldn't be so hard. We would still need to manage only one cluster, even though each tenant gets a separate one with full permissions, with its full glory. Now, let me backtrack a bit and explain potential issues with having multiple tenants in a single cluster, like what I showed you with Capsule. And if you haven't seen Capsule, please go and check it out. The link is somewhere above my head. So if you have multiple tenants within the same cluster, one way or another, they end up having their own namespace or namespaces. Each tenant can have multiple namespaces. Here are the problems with that. Each of those tenants cannot have cluster-wide permissions to do stuff. Such tenants cannot create custom resource definitions. They cannot install any of the third-party applications that have any type of cluster-wide resources, which is like half of third-party applications. Tenants cannot even list namespaces. They cannot even see which namespaces they own within a cluster. So that inability to create cluster-wide resources or even to have read permissions for cluster-wide resources, at least among those that belong to a specific tenant, is potentially a huge issue. Because in those cases, tenants are restricted. They cannot do anything they want. And even if you say, hey, I do not want my tenants to do anything they want, you still want your tenants to feel like it's their own cluster. And not being able to do something as simple as kubectl get namespaces to see what namespaces belong to me is an issue. And the real problem is that multiple tenants share the same cluster. And we are going to try to overcome that problem. We are going to try to figure out how to give each tenant their own cluster, but those clusters will be virtual clusters inside of a single Kubernetes cluster. And those tenants should feel like they own the whole cluster. They might never even find out that their cluster is virtual cluster, one of the many clusters inside of a single Kubernetes cluster. And we are going to try to do that with vcluster. I go through many tools in this channel and I almost always find a fault in every single one of them. In almost every single tool that I explore, I end up saying it's okay or it's good, it's horrible, and there is always that but. But you shouldn't use it because of this and that. There are very few that I consider absolutely amazing, and this one might be one of those. But let's reserve that opinion for the end of this video. For now, let's jump into the practical part of this session. Let's see vcluster in action. I already created a cluster and I already installed vcluster CLI. That's the only thing I did. If you follow the channel, you already know the drill. All the instructions, all the commands that I will be executing are in a gist, and the gist is in the description. The link to the gist actually is in the description. So if you want to follow along, you know what to do. So let me show you how to create a virtual cluster for a tenant. So the first thing I will do is create a namespace. Now you might say, hey, are you going to give your tenants a namespace? And the answer is both yes and no. I will not really give tenants a namespace, but I will need a namespace where that virtual cluster will be running. So I will create a namespace for a team called a team. That will be my first tenant in this cluster. So kubectl create namespace a team. And there is one more step that is not necessarily mandatory, but it's very welcome, and that is to create a service inside of that namespace which later on will be used to access that virtual cluster. I would love if vcluster would provide us with means how to create that service easily. It doesn't, so I created it myself. It's not really a big deal. I will create a service that is load balancer type, and that's about it. It's just a simple service. and it needs to have specific selectors. You will see later why. Basically, vCluster will create a service with those selectors. Anyways, I will create load balancer service. So let's just get going and do kubectl -- namespace a team and then apply -- file name service YAML, right? And there is one more thing, the last thing missing before I actually start creating virtual clusters. And that thing missing is that I need to know the IP of the load balancer service. It could be not port, by the way. Anyways, I need to know the IP because I will need it by the time I start installing a virtual cluster. And I can get that IP by executing kubectl -- namespace a team, and I will get the service called a team cluster. That's the name of the service that I created. Here we are. Here's the definition, right? So, and I will output it to YAML. And what I really need, here we are. My load balancer was not created yet, so I will need to wait for a couple of moments. Let me fast forward to the end of the process actually. There we are, the load balancer was created and this is the IP. I will copy that IP and this is the last step, I promise. I will modify Helm values file that I have here and I will replace this IP, which is from me practicing that thing, and I will put the IP of the newly created service, right? This was a bit annoying and painful, and I wish that vCluster made this simpler, but it didn't. Still, now we are finally ready to install a virtual cluster inside of this real Kubernetes cluster. And we can do that by clearing the screen first, and the command is vcluster in the namespace a team, and we want to create a virtual cluster called a team. It can be any name, and extra values are helm values.yaml. There we are. A virtual cluster is being created. It will take a couple of seconds. I will count to 5. 1, 2, 3. Okay, there we are. That's it. We have a cluster running inside of a cluster, and our tenants should be able to use it, right? They should be able to access that cluster without knowing that it is a virtual cluster. For our tenants, for our users, it will feel like it is a real cluster, even though it's virtual. Now, before I proceed, there is one grievance I have with the vCluster. I would love if this command would have, let's say, -- output YAML or something like that. I would love if it would output YAML so that I can store that YAML in a Git repository. Now, if you go to the official documentation, you will find instructions how to generate, copy and paste and modify YAML, but it would be great if the CLI does that. It doesn't. Now, while I'm still admin of this cluster, let's say what we got. Kubectl get all in the namespace a team, and this is what we got, right? Those are the pods that constitute the virtual cluster. There is a pod a team O, which is basically based on a stateful set. So virtual cluster creates a stateful set that contains a pod. Here's the pod. That pod has 2 containers, and those 2 containers are the whole cluster. They're extremely lightweight. They're as lightweight as it can get. I will explain the architecture and how it works later. For now, just think of this as being a pod that is a whole cluster, excluding core DNS. Core DNS is running still on the parent cluster or the base cluster, right? Now, what I need to do next is to enable other people, let's say that team A or A team, to become a tenant in this virtual cluster, or to be more precise, to become a tenant in my cluster and owner of that virtual cluster. I want my tenants to feel like they own the virtual cluster, but not the parent one, not the real cluster. So what I need to do is create a kubeconfig for those tenants, and I will do that with yet another command, which is vcluster in a namespace a team, and I want to connect to the virtual cluster called a team. I could have multiple virtual clusters in the same namespace, and I will specify the server, which is https and then whatever is the IP of that load balancer virtual service that I created initially. There we are. I have kubeconfig, and let me show you that kubeconfig. This is the kubeconfig. Doesn't matter, it's just a kubeconfig that now I can ship. I can send to my tenants and tell them, hey, I'm giving you a whole cluster. You don't need to know that it's virtual or it's not virtual. I'm giving you access to a cluster, full admin access, even though that's virtual cluster, right? So now imagine that I'm changing my role. I'm not cluster admin anymore. Now I'm a tenant. I'm a member of the A team. I'm the admin of the A team. Doesn't matter what I am. What matters is that I'm not really a cluster admin anymore. So I'm a person who got that kubeconfig, and I will export kubeconfig variable to be whatever is the current directory, kubeconfig.yaml. So keep this in mind. I'm a tenant now. I'm inside of that virtual cluster. I do not have access anymore to the cluster itself, to the real cluster, to the base cluster. So what can I do? You gave me access, somebody gave me access to the cluster, and I can do kubectl get namespaces. Let's see what we'll get. There we are. These are the namespaces of that cluster. Yeah, I have kube system, kube public, kube node lease, and default, right? It's a whole cluster for me. I can deploy my applications from now on. I can say, hey, this is my application, app YAML, that has an ingress, it has a service, and it has a deployment. Just a silly application to show you how virtual clusters work. And I can say, hey, how about me creating a new namespace? Kubectl create namespace production. And how about deploying that application to production? I can say kubectl -- namespace production. That's a namespace that I created as a tenant right now. And I can say apply -- file name app.yaml, right? And now my application soon will be running in production, but not production of the cluster itself, but production namespace that I created inside of a virtual cluster that I've been given access as an admin. If I list the namespaces, get namespaces, we can see that the production namespace that I created is there. If I list the resources, let's say kubectl -- namespace production, and what should I do? Get deployments. We can see that the application was deployed, right? The deployment, one of the resources of the application is there. I can list the pods as well, right? Here are the pods in production. I can see the 3 pods because that deployment has 3 replicas. I can see services, right? They're also there. And what else? Ingress, yes, that application has ingress. Here we are, and ingresses are there as well. What else? Let's say nodes. Yes, let's list the nodes. Kubectl get nodes, right? And there are even nodes in this cluster. Me as a tenant in a virtual cluster, I see the nodes of the physical cluster. I cannot change them, and I actually do not see all the nodes. I see only the nodes where my pods are running. But since I have 3 pods, they are distributed across 3 nodes, and I can even see the nodes. It completely feels like this is my cluster with no restrictions. I can do anything I want within that virtual cluster without affecting the base cluster, the real cluster, the cluster in which that virtual cluster is running. Now that you saw how it looks like being a tenant in a virtual cluster, actually there's not much to see because it feels for tenants as if they're in a real cluster. No restrictions, they have their own cluster and they do not even need to know that it is a virtual cluster. But let me switch back. Let me become again the administrator of the cluster itself, the real cluster, because I want to show you what happened in the background while the tenant was working with the virtual cluster. So I'm going to unset kubeconfig, right? I'm going to remove the config of the virtual cluster and go back to the config of the real cluster. So let's start by listing namespaces. Kubectl get namespaces. And the important thing in the output that will appear just now is that production namespace is not there. While I was a tenant, I created a namespace called production, and that namespace does not exist in my cluster, in the real cluster. It exists only in the virtual cluster. Similarly, if I do kubectl -- namespace A team, right? That's the namespace where virtual cluster is running. I can do get deployments because the tenant, the previous me, created a deployment, and that deployment does not exist. Again, that deployment was created in the virtual cluster. That virtual cluster is actually a real Kubernetes cluster of sorts. It is K3s cluster running in a pod. So scheduler is there, and the deployment that I created is there, and so on and so forth. All the resources I created were created inside of the pod that acts as a virtual cluster. Now, if you understand Kubernetes, you might probably say, hey, that's actually a bad idea, because that means that the pods are running inside of a pod. So it's containers inside of containers, and that's a bad idea. That's a very bad idea, but that is not the case. It is true that the resources created inside of the virtual cluster are being created inside of the pod, inside of the containers of the virtual cluster. There are a couple of exceptions. Pods and services and ingresses are actually created in the real cluster. So the scheduler inside of the virtual cluster is managing all the resources, but when the time comes to create the pods and services and ingresses, it delegates that to a scheduler on the parent cluster or the real cluster. And that means that the performance, the networking and storage and what's or not is the same inside of the virtual cluster as inside of a real Kubernetes cluster, because the resources that matter, which is pods, services and ingresses, are created on the base cluster. And I can show you that. Even though the deployment is created inside of the virtual cluster, and that deployment created a replica set inside of the virtual cluster, and that replica set created pods, those pods are actually running on the host cluster. And you can see it here, right? When you're inside of the virtual cluster as a tenant, you see the pods as well, and you see them with their proper naming. Here, inside of the base cluster, those pods are using naming conventions so that there is a guarantee that there will be no collision between the names. And the 3 pods that you saw inside of the virtual cluster, you can see them here as well. They are actually running on the host. And the same goes for services, and the same goes for ingresses. Those 3 resource types are running on the base host, and everything else is inside of virtual clusters. While at the same time, all those resources from the user perspective are managed inside of the virtual cluster. Finally, as an admin, I can say, hey, no more, I do not want to give you virtual cluster anymore. I don't like you, I will revoke your privileges, I will just remove the virtual cluster. Here's how I would do that. vcluster namespace a team delete a team, right? I'm deleting the virtual cluster. And the interesting part here is that I did not only delete the virtual cluster, I deleted even the resources that the virtual cluster created on the base cluster, on the real cluster. And I can show you that. If I do kubectl namespace a team get pods are not there because there is that parent-child relationship, and as soon as the virtual cluster was deleted, all the resources created on the main cluster, on the base cluster, were deleted as well. I rarely get so impressed with the tool as I got with vcluster. And I got even more impressed when I saw the date of the first release. The release 010, the oldest release I could find in the project, was made in April 2021. And I'm recording this in June 2021. So I'm recording this only a few months after the first release of the project. And it is already doing almost everything I would need it to do. It is a mature project that is only a couple of months old. I cannot even imagine how far the project will get within a year. It has a strong possibility to become the de facto standard for multi-tenancy in Kubernetes. I showed you Capsule before, which is also awesome. It uses different approach to multi-tenancy, but if I would have to place bets on one of those 2 projects, I would say that vcluster has a slightly better chance of becoming the standard. It has very low overhead because the virtual cluster itself is based on K3s, and K3s hardly uses any resources. It is the most resource efficient type of Kubernetes cluster we have today. So each virtual cluster will not consume any significant amount of resources. And the workloads running in those clusters are not going to have any performance penalty because the workloads that matter are running on the base cluster, on the parent cluster, on the real cluster, while everything else, including the scheduler and deployments and stateful sets and whatever else you're creating, is running, is being managed by a virtual cluster and not by the parent cluster. That's how the tenants have the full control of those clusters that they are given, because everything is happening in those clusters except that the creation and management of pods is delegated to the main cluster, to the main scheduler, to the one running on the real cluster. So cluster admins do not have an overhead of managing real clusters, of managing many real clusters, one for each tenant. Tenants, on the other hand, have a full control of what is happening inside of their virtual clusters, and from their perspective, they're not getting a virtual cluster, they're getting a real cluster, because they can do inside of those virtual clusters, all the same things that they would do in a real cluster. There are no restrictions. They can apply cluster-wide resources, they can manage their own namespaces, they can do anything they want. They could install, for example, Argo CD or Flux and manage their workloads in a GitOps way. They could have pipelines running in those clusters and so on and so forth. Tenants can do in their virtual clusters all the things that they would normally be able to do in real clusters without the overhead of managing many real clusters and without performance penalties. And virtual clusters do not need to be created only for tenants. They do not need to be owned only by teams. I can easily imagine other use cases. We could have a staging environment as a virtual cluster. We could create virtual clusters for every pull request and deploy applications there and test them, and then destroy virtual clusters without the fear that whatever we are deploying is going to clash with something else that we might be deploying. We could combine virtual clusters with policy management, for example. We could use Kyverno or OPA Gateway or whatever else you're using. Essentially, we could do in virtual clusters everything that we could do in real clusters. Try it out and let me know what you think. You ask me in one of the comments what I think about vClusters, and that's this video. Keep asking questions, keep demanding what I should do next, and I promise that I will do it sooner or later. I don't guarantee when. See you next time. Cheers.